Okay, here we go. This is it. We did it. The last section in trig for the year, section 11.7. So I think I accidentally said in the previous video in 11.6 that 11.6 and 11.7 were all about polar. I lied. It was a P word, but 11.7, again, we're going to talk about another way that we can deal with trigonometric functions, and they're called parametric equations. Okay, so right here you can read about parametric equations. Basically, what it is that you use two functions to make a coordinate point. Okay, and the graph is a plane curve. So what they mean by a plane curve, it's just an XY plane. Okay, but your X values and your Y values are all determined by the two functions that are making it up. So one function is f of t, that will tell you x. The other function is g of t, and that will tell you the y. And t is just some real number in some interval. Okay? So, yeah, I mean, that's really what parametric equations are. In our calculator, again, under mode, so right there is parametric. So we want our calculator to be in parametric. Okay, so we scroll down, scroll over, hit parametric, and then now when you hit that y equals, notice it says x equals y equals, which is what's going to happen because this is going to be our f of t function, this is going to be our y of t function, and in Zoom, make sure that we scroll down to standard so that way our window is set up the way it should be. So again, if you hit Zoom standard, it looks like a normal graph. But if you look under the window, see things have kind of changed here. And we'll talk about this soon enough. Okay? So there's making sure that our calculator is in the proper mode. Again, you hit mode. Make sure that you're in parametric. All right? So again, parametric, it makes a set of points, x, y, but it's made up of two different equations, okay? Where x is equal to f of t, y equals g of t, and t is just a number in the interval, okay? All right, so let's talk about what you're going to be doing. First things first, whoa, too far. All they want you to do is tell us the ordered pair. Okay? They want you to tell us the ordered pair to this. Well, that's simple. They're telling you what t is here. So take this number, plug it into t in the top, plug it into t in the bottom, and you've got your ordered pair. Okay? So x is equal to 2 times 3 plus 5. Okay? Well, what's 2 times 3? That's 6. 6 plus 5, that's 11. So we know our point starts with 11. To find the y value of the point, take the 3, plug it into t. So negative 3 times 3 plus 7. Negative 3 times 3 is negative 9. Negative 9 plus 7, negative 2. And there you go. That's how you find the ordered pair for a parametric equation. Okay? Promise you it's that easy. All right, so the rest of these, what they're going to want you to do is they're going to want you to graph and then tell us what the rectangular equation is. So this piece of information right here is for the graphing part. So if we go into my calculator, so we're looking at 0 to pi over 2, if I remember right. Let me make sure then. Yes, pi over 2. So when you go into window, this is where that 0 and pi over 2 go. So you can see that our minimum is 0, but come down here, we need to change the max to pi over 2. Okay? That's where that information goes. All right? So let's go back to y equals. And all you got to do is put these equations in, and it'll show you what the picture looks like. And then you just match it out of the 4 that are down below. Okay? So when we look at this, let's go into our calculator. So we're going to put 11, and in order to get cosine squared, you got to put it in parentheses. If you hit the x value, notice it's now a t, which makes sense because we're in parametric. And that's how we get cosine squared, because that's what our first one, our x is, 11 cosine squared t. And that's how you put the squares on cosines. So we just scroll down. We're going to do the same thing again. We're going to have 11, parenthesis, sine, hit the t button, which is just your x, and square it. Hit graph. And we don't see anything. Is my graph on? Yeah, it should be on. Zoom, go down to standard. There it is. And again, though, our window should be from 0 to pi over 2. Graph. Weird. I can't remember why this one doesn't show up on our graph. It should be there. Let me troubleshoot real quick. Look at the problem for just a second. Where's this guy at? I know there's one like this in your assignment. Yeah, there we go. Oh, I guess actually for this question, they actually don't really want you to look at the graph. But if we kind of zoomed out a little bit and actually looked at the standard equation of this, the standard form, so we don't really need the graph of this, but there's what it would look like if we weren't concerned about the range. So some of the questions actually just want the equation. Some of them will want both, the graph and the equation. This is one of those questions where it actually didn't ask for the graph. It just wants the equation. Okay? But if you look at this thing, it looks like a line segment. Okay? Maybe if we zoom out a little bit. Let's just say zoom out. See? It looks like a line segment. Okay? So parametric equations, kind of when you look at their graphs, it's like you're looking at part of a graph. Okay? That's what parametric equations do. You're looking at part of a full graph. So you're looking at part of a possible line here, depending on what happens over here and what happens down here. Okay? So go back to Zoom Standard. All right. So let's go in and let's find the rectangular equation for this idea. All right. So let's jump into our paper. So some things that you're going to look at and some things that are going to seem really, really weird. So what you want to do is we actually want to isolate the cosine squared and the sine squared. Because if we can isolate them, what you're going to use is some of those identities that we know about from the past. Like for instance, we know that cosine squared plus sine squared equals 1, right? This is why we want to isolate the cosine squared and the sine squared. Because if I know what cosine squared is, I can plug it into cosine squared. If I know what sine squared is, I can plug it into the sine squared. Okay? So, if I can take x equal to 11 cosine squared t, let's get cosine squared by itself. How do I get rid of the 11? Divide by 11. And now we know that cosine squared t is equal to x over 11. And let's do the same thing for sine. Y is equal to 11 sine squared t. Let's get sine squared by itself. Divide by 11. Divide by 11. So sine squared t equals y over 11. So all we're going to do now take what we know and plug it in. We know that cosine squared is x over 11. So I'm going to plug that x over 11 right there and get rid of the cosine squared. We know that sine squared is y over 11. So I'm going to plug that right there. Okay? So what we have then is x over 11 plus y over 11 equal to 1. So to finish this up, we don't like having fractions all over here like this. Although it's fine, but they actually want it to be y equals. So first things first, let's get rid of the fraction. In order to get rid of the fraction, all you got to do is just multiply everybody by 11. Okay? So if we multiply everybody by 11, that's going to give us x plus y equal to 11. Now get y by itself. Well, subtract x, y equals negative x plus 11. And that makes sense why it looked like a line segment, because this is the equation of a line. A line that has an intercept at positive 11 and a negative 1 as a slope. Okay? And that's what the majority of this is about. Plugging in the calculator, looking at the graph, and then coming over here and finding the equation for it. Okay? So let's look at this guy. So this one, I definitely know there's a graph to it. Okay? So if we go, let's plug all this information into our calculator. Again, this goes into the window section for t. So we got negative 3 and 2. So window section, window. We've got negative 3 and 2. Come up in here. We're just going to clear these out and put our equation in. So our top equation is 3t minus 5. So 3t minus 5. Our bottom equation, if I remember right, I believe it was t squared. Yeah. T squared. And if we hit graph, again, not showing up. And I have a feeling it's due to this window. Okay. Let's take, well, not this window, but it's to this step. That step is really huge. Let's call this pi over 2. Let's see what that does. That's really weird, because that's not really what our graph looks like. So let's go back, zoom, standard. There it is. So weird. So make sure that when you're graphing, just go in and put that zoom standard stuff. So here's what our equation looks like. Okay. So let's go ahead and solve this. And no, that's not what our equation looks like. Why is this coming out weird? Is our mode right? We're in parametric. Zoom. Scroll down to standard. We need to adjust our window. And it's this step. Why is this step so big? Let me check something real quick. Looking at my other calculator that I have right in front of me, because this was working on that one. So let's go into, sounds like an emergency going on. So mode, parametric. Let me look at my window in here. And this is the steps that I have. It has my steps going by. Zoom. Let's make sure that's standard. Yeah. My step is going by 0.1308999 693.89957. I would put that in there and see what it all does, because this is what my steps were going by, and this seems like it's working a lot easier. Oh, I know why. Because my mode in this is in radians. That's the difference. On here, I'm in degrees. Let's change that to radians. Let's go to zoom standard. There we go. Now we're looking at it a little bit. Hey, there's that step that I was talking about. But we need to change our picture because we are working from different numbers. We're working from -3 to 2. So if I come in here and I put -3 to 2, and now hit graph, now we got it. There it is. There's what our graph looks like. See how it's like part of a parabola. So let me go back. Let me show you that other one real quick that we are just working on. Now that I figured out what it was. Make sure your calculator's in radians, ladies and gentlemen, when you're dealing with parametrics. Calculator needs to be in radians, not degrees. Okay? So if I go back, because I always like to, make sure that you understand things the way they look. It is, again, this one is going to look like a line segment. So that wasn't a lie. But let's make sure that we can see it this time. Cosine t and squared and 11 parenthesis sine t squared. All right. And then remember on this guy, we were going from 0 to pi over 2. And we hit graph. There's that line segment that we saw a couple seconds ago. Okay. So we were doing everything right. I just had to make sure that, please make sure that your calculator is in radians when you're doing parametrics. I almost messed that up. All right, so you can see that it's a line segment verifying what we did a couple minutes ago. Okay? So going back to this one, again, we had 3t minus 5. Oops, that was x. This guy down here was t squared. And this one was 3t minus 5. And if we adjust our window to that number that we had, -3, 2, -3 and 2, hit graph. Now you can see what it looks like. Now on this one, if in the actual assignment, it has like a little, like there'll be 4 graphs, and then right below those 4 graphs, it also tells you some other things. Like it tells you how to adjust your max and min. So to even see, because this isn't really the full picture. So in there, it actually says down here that your minimum should be a -20. And this is on the problem when you're looking at the graph. -20. The maximum should be a +20. Scroll down. The minimum y should be a -20. The maximum y should be a +20. And then now you actually see the full graph. That's really what it looks like. So when you guys are doing these problems and you're looking at the graphs, if you see something on by the graphs that says x min equals, x max equals, y min equals, y max equals, they are wanting you to not only change the t min and max, but they want you to come down here and change these guys as well too. Okay? So if you see that x min, x max, y min, y max, they're talking about these numbers down here. Change them. So here is what that picture looks like. But again, they want us to find the rectangular equation for it. So let's do that. Okay. Now, in this one, here's what's cool. It's going to be kind of like substitution. And what we're going to do in this is we're going to get this t by itself. And once we know what this t equals, we can take our equation and plug it into y and get the rest of everything that we need. Okay? So this is kind of going to be like substitution. So we're going to take the x coordinate piece here and we're going to plug that into the y. Where before we used this idea of a Pythagorean identity, cosine squared plus sine squared equals 1, okay? But in this one, we're going to do substitution. So those are kind of like the two techniques that you kind of use throughout this. So if we have x equal to 3t minus 5, add 5. So x plus 5 equals 3t. And then we're going to divide by 3. And now we know what t equals. X plus 5 all over 3. And we can take that and we can plug it in to the y value there. And that will give us our rectangular equation because we will no longer have t. We'll have y equals x plus 5 all over 3 squared. So all we have to do is square that information. Okay? So what that really looks like is we have x plus 5 all over 3 times x plus 5 all over 3. How do I multiply fractions? I multiply across the top and across the bottom. So y is equal to, well, 3 times 3 on the bottom is 9. And on the top, you got a FOIL. So x times x, x squared. X times 5, 5x. 5 times x is another 5x. So that's 10x total because you got 5x and 5x for the inner and the outer. And that gives you 10x. And 5 times 5 is 25. And right there is a rectangular equation. Although what they like to do is they like to separate these out into their 3 fractions. So they like to call this 1/9 x squared because there's a 1 in front of the x, and you put that 1 over the 9, plus 10/9 x, and then plus 25/9, which makes sense because our graph was a parabola. This is the equation for a parabola, or in other words, a quadratic. And there you go. They're not trying to do anything really tricky in here, okay? When it comes to, Pythagorean identities to know, cosine squared plus sine squared equal to 1 is a good one. Another Pythagorean identity to know. Oh, where is it? It is. Give me just a second to flip through my notes. There they are. Another good one to know that you might want to use, hint, hint, wink, wink, nudge, nudge, is tangent squared plus 1 equals secant squared. You might see a kind of problem where we want to use this pop up sometime. Okay? Hint, hint, wink, wink, nudge, nudge. All right. Go ahead. Try this one on your own. See what happens. Okay? Pause the video now. Go for it. Okay, so the first things first, go ahead and look at the graph of this. Now that we know our calculators in radians and that it's running functionally now, again, I'm going to go back and I'm going to hit zoom standard. In the assignment, this kind of problem does not have us adjust the window any, so you don't have to worry about that part. So we are going to put in the 4 and 0 for t. So was it 4 and 0? No, 0, 4. I was like, that's weird. Why would I have the bigger number be first? So 0 and 4, leave that alone. Go in here and put in your equation. So clear that out. let's clear this guy out. So we're going to put in the square root, alpha y equals, and it is t over 3. So t over 3. Scroll down to the next guy, and we're going to put in 2t minus 1. 2t minus 1. And graph. And there's what it looks like. And you just find the graph that matches that one. Okay? Now, to find the rectangular information, do the same thing that we just did, like on the last one. Let's get this t right here by itself. Once we know what that t equals, we can plug it into the y, and we're done. So, x equals square root of t all over 3. How do I get rid of a square root? We square it. So that gives us x squared equals t over 3. How do I get t by itself? Multiply by 3, multiply by 3. T is equal to 3x squared. So, now you know what t is. Take this and plug it into the other equation. So y equals 2 times 3x squared minus 1. Y equals 6x squared minus 1. And there's the equation. And now you're done. See, nothing crazy, I promise you. All right. I think this is my, nope. I got 2 more, and then we have one word problem that we have to deal with. And that's what 11.7 is going to be like. Okay. Sorry about that. Had to pause for just a second. So now, again, they'll want to know what what does the graph look like? So we go into our calculator. We'll come in here, change up. We're going to put in 0 and 2 pi. Okay. Come in here, we'll clear out these equations. So we have 3 plus 5 cosine t. So 3 plus 5 cosine t. And then the other one is 4 plus 5 sine t. 4 plus 5 sine t. Okay, so graph. And there's what it is. It's a circle. So we know that our equation that we should be writing should look like a circle. Okay? All right, so let's go write the equation for this. So this one, again, what's going to help us on this is getting cosine by itself and getting sine by itself, because we have a trig identity that says cosine squared plus sine squared equals 1. And if I knew what cosine was, I can plug into it. If I knew what sine was, I could plug into it. So x equals 3 plus 5 cosine t. So subtract 3. X minus 3 equals 5 cosine t. Divide by 5. Divide by 5. So now we know that cosine, Now we know that cosine is equal to x minus 3 over 5. Let's do the same thing for sine. Y equals 4 plus 5 sine. Subtract 4. Y minus 4 equals 5 sine t. Divide by 5. Divide by 5. So sine t equals y minus 4 all over Okay? So all we got to do now, since we know what sine is plug the y minus 4 over 5 in for sine. Since we know what cosine is, plug the x minus 3 over 5 in for cosine. Easy peasy. So what we have now is x minus 3 all over 5, and it is squared because it was cosine squared there, and all we did was plug in the cosine, plus y minus 4 over 5 squared equal to 1. So we need to square this, and in fact, really all we want to do is we want to square the bottom. So what we have on top is x minus 3 squared all over what is 5 squared? 25. Notice I didn't distribute the square through there because that doesn't happen. Okay? Plus, do the same thing over here. Leave the numerator alone, so we're going to leave the numerator squared, but what is 5 squared in the denominator? 25. All we have to do now, just like what we did before when we had the 11 in the denominator, we don't really want that, so we're just going to multiply this whole thing by 25 to get rid of it. And what we end up with is the equation of a circle. X minus 3 squared, because the 25s cancel out, plus y minus 4 squared, because the 25s cancel out, and 25 times 1 is 25. And again, that's that equation of a circle, as we've seen before, where the center is at 3, 4, and it had a radius of 5, which was what you saw on our graph here. The center is at 3, 4, and if we count over to the right 5, left 5, up 5, down 5, that's our circle. So it makes sense that this is the final answer, because our picture was a circle. Okay. Last one, then our word problem, and that is your trig semester. Okay? So, again, on this one, the cool thing is we don't want the rectangular information. We just want to know, what does this picture look like? So cool. Just go to my graph and let's graph it. So we're 0 and pi over 2. So we change this to pi over 2. So over here, all we're going to do is have, I believe it's cosine cubed, sine cubed. So, parenthesis cosine t, parenthesis, and cubed. Come down here, parenthesis sine t, parenthesis, and cubed. Hit graph. Really weird. Again, go in here and scroll down to that zoom standard again. Always just double check that because it's a new graph. There's what it really looks like. Kind of like a diamond. Okay? So you just look at the 4 graphs, find out which one looks like that diamond, and that's the answer. So that's all this one was. Just use that graphing calculator. Okay? And it kind of looks like a diamond. Actually, what it's really doing in there, this is 1, negative 1, negative 1, 1, negative 1. Sorry, this should be a positive 1 over here. My bad. What it's really doing is swooping in like that. So it's kind of like mini parabolas there. That's what it really looks like when you zoom in on that. Okay? So that's the graph that you want. All right. Last piece, word problem. So I promise you this is not that bad. Okay? So here we go. So we know that if an object is thrown on the moon, then the parametric equations of flight are x equals parenthesis v cosine theta parenthesis t, y equals parenthesis v sine theta parenthesis t, minus 2.66 t squared plus h. Okay, so it says estimate the distance that a ball is thrown at 89 feet per second. This guy right here, that's our velocity. At an angle of 48, so this one right here, that's our theta. With the horizontal travels on the moon, if the moon's surface is level, so we're assuming that it's level. Okay, it says assume the initial height is 0. So this one right there, that's h. So we need to plug this information in, and then we'll talk about how we're going to find that distance, because it's a lot like doing substitution. But instead of working with the x part, we're going to work with the y part and then plug into the x. Okay, so it is like substitution, just instead of going from x to the y equation like we did before, we're going to go from the y to the x, and that answer for x will be the end solution. Okay, so if we plug in, we get x equal to v, which is 89, cosine 48 degrees, t. Well, we can go to our calculator and figure this part out. X equals, so let's exit out of this. Let's just clear that out. Clear that out. Quit. So that was 89 cosine 48, and definitely make sure that you go into the apps and let it know that this is in degrees, because right now we are in radians. Okay, close it up, and there's our number, 59.55262397. So we want to keep as most of this as possible. Okay, so we know that this is 59.55, let's see here, 2623. 2623, I think it was 97 t. So we want to keep as much of that as possible. All right, so there we go. Now we're going to do the same thing for the y. All right, so for the y, we've got y equals 89 sine 48 degrees t squared. And then we have, or sorry, t, not t squared, minus 2.66 t squared. H is 0. So you can write plus 0, but you don't really have to write plus 0. Okay? So the equation that we're working with is that. So let's go ahead and figure out this 89 sine 48. Get that number. So I'm just going to go back up and grab this, because all I got to do is just change the cosine to sine. Okay? So there's our number, 66.13988,947. So we've got y, let's make sure I'm writing. Y equals 66.13988,947. T minus 2.66 t squared. So down here, this is an equation that we can actually solve because it's y equals, right? So take this bottom equation, set it equal to 0, and let's solve for t. Because once we know what t is, we can plug that back into the top one. Okay? So we're taking the bottom equation. I'm plugging in 0 for y, because it's just a normal equation to solve. Okay? In order to solve this is just a factoring problem. Both of these terms right here share a t. So we're going to pull that t out. 0 equals, pull the t out, and you got 66.13988,947 t. We pulled that t out of there. There's no more t left there. Minus 2.66 t. And all we do is set these equal to 0. So t equals 0. There's one of our answers for t. And the other one will be 66.13988,947 minus 2.66 t equal to 0. So after some solving here, t is equal to negative 66.13988,947 divided by negative 2.66. So t in our calculator, negative 66.13988. You see why I got to keep everything pretty exact, because if we rounded this and rounded this, there's going to be a lot of rounding in the end. We need everything to be somewhat exact. Divided by negative 2.66. So there's our new number. So our other number is 24.80866,072. So 24.8646. Sorry, 8086. Eight 6072. 072. So there's our two numbers. Okay. Oh, I put too many sixes in here. No wonder. So let me recapture that. It's just going to modify our decimal just a little bit. So it should be 24.8646. No wonder I put that 46 earlier. 201. My bad. So 864620, I think it was 7. 201. There's our t value now. Even better. So all we're going to do is take these two values and plug them in to what we know right here. And that will tell you how far our ball has been thrown. Okay? So we're going to take that. Come on, you. So x is equal to 59.5526. 5526 2397. 2397 times 0 Well, you know that that is 0, because anything times 0 is 0. So one of our answers could be 0 feet, but that doesn't make any sense because we did throw the ball. So this answer actually gets thrown out. So that means this other one will be our answer. We'll take 59.5526,397 times 24.8646,201. And the problem will want you to round to the nearest whole number. Okay? So if we come in here, we want to use this number and multiply it by that number. So all I'm going to do is scroll up, grab that number, times, scroll up, grab the other number we want, hit enter, round to the nearest whole. The 7 says, hey, 0, go up. So the ball went 1,481 feet. 1,481 feet. And there we go. That's how the last problem in your trig assignment will work. And that, my friends, is 11.7. And that wraps up your trig semester. Thanks for joining me.